Knowledge distillation is a powerful technique in machine learning that allows a smaller model to learn from a larger, pre-trained model. This process is particularly useful for deploying models in resource-constrained environments. There are three primary training methods for knowledge distillation: offline distillation, online distillation, and self-distillation. Offline distillation is the most traditional and widely used approach in knowledge distillation. In this method, the teacher model is pre-trained on a dataset and then frozen, meaning its weights are not updated during the training of the student model. The student model learns from the teacher by trying to replicate its output predictions. This method is straightforward to implement since it does not require simultaneous training of both models. Many existing techniques and frameworks are built around offline distillation, making it easier to apply. The performance of the student model heavily depends on the choice of the teacher model. A poorly chosen teacher may lead to suboptimal student performance. Online distillation addresses some of the limitations of offline distillation by allowing both the teacher and student models to be trained simultaneously in an end-to-end manner. This means that both models can update their weights based on the same training data, which can lead to improved performance. The teacher can adapt its knowledge based on the student's learning progress, potentially leading to better performance. This method can enhance the student's ability to generalize, especially when the teacher model is large and complex. Increased complexity in training, as both models need to be managed simultaneously, requires careful tuning to ensure that the teacher model does not overpower the student model during training. Self-distillation is a unique approach where the student model learns from its own predictions. In this method, the model is trained in a way that it uses its own outputs as soft labels for further training. This method eliminates the need for a separate teacher model, simplifying the training process. By learning from its own outputs, the model can potentially improve its performance on unseen data. The effectiveness of self-distillation can vary significantly depending on the architecture and initial training of the model. It may not always lead to improvements, especially if the model's initial predictions are not reliable. This table shows the training complexity, adaptability, performance dependence, and use cases under different training methods. In general, offline distillation is the easier one, and it can be a default or baseline training method. If special requirements are needed, such as online training, we may consider other approaches. In summary, each method of knowledge distillation has its own strengths and weaknesses. Offline distillation is the most established and straightforward, while online distillation offers dynamic learning capabilities. Self-distillation provides a unique approach by allowing models to learn from their own predictions, making it a valuable technique in certain scenarios. The choice of method often depends on the specific requirements of the application and the resources available.